Okay, let's discuss the question number 47 from thermodynamics. This is from thermodynamics test series 4, the IC engines part basically. Okay, so what is given? A 40 kilowatt engine is given, so the power of the engine is 40 kilowatt and it has a mechanical efficiency 80%, so 0.8. FP frictional power is assumed to be constant. Okay, so friction power is assumed to be constant with load, so it doesn't vary with load. So if I change the load, then friction power in the engine doesn't change with the load. Okay, so that is the assumption that is given. Now what is the approximate value of the mechanical efficiency at 50% of rated load? Okay, so this 0.8 is at the rated load, and now what is asked is at 50% of the rated load. At 50% of the rated load, what is my mechanical efficiency? Okay, so now okay, so let's solve this problem. So one thing you have to understand is the power that is produced by the engine, okay, is after all my cooling losses from the cylinder jacket and all that, the power that comes out is after the heat losses, and that is indicative power, which is denoted by IP, and that basically becomes my brake power, which is used for supporting the load. But some is also wasted in friction power at the bearings, friction at the bearings and your crank, the crank and whatever the interfaces are there, mainly at the bearings. Okay, so now, and this PP is what is useful power to drive a motor or whatever. Okay, so now, so BP, how do I measure BP? BP is my load into the speed. That is how I measure load into the speed. Load here it is in torque, you can say in terms of torque. Okay, now my mechanical efficiency is basically my brake power by my indicative power, because that gives an indication about how much friction is there. If there is no friction, hypothetical case, BP will become IP, mechanical efficiency is 100%, but that's not the case. Okay, now for given power output, which is 40 kilowatt, and my mechanical efficiency is, so just I'm using this equation, 40 kilowatt is my BP, which is given, and IP I don't know. Okay, and efficiency is 0.8. This is for the full load rated load. Okay, so IP whatever I'll get is 40 by 0.8, which is 50 kilowatt. Okay, so now I just use this equation to get the friction power, because friction power is constant, so I can use it at the half load, same value at the half load. So FP is IP minus BP, which is 50 minus 40 is 10 kilowatt. Okay, so FE I can use later. Now at 50% of load, so 50% of load means my BP2 will be basically 50, assuming that speed is constant here, speed is constant, so, and the load is reduced, so my brake power will be reduced. So 0.5 into the initial BP, which is 0.5, because the load is half and speed is constant, so it will be 0.5 into 40, which is 20 kilowatt. Okay, so now my FP2 is nothing but FE1, because that's given in the problem, so that is 10 kilowatt, and so IP2 indicative power will be BP2 plus FP2, so it will be 20 plus 10, it will be 30 kilowatt. Okay, so now my efficiency, mechanical efficiency will be, the new mechanical efficiency will be the BP2 by the brake power by the indicative power at this state, so which is the stage 2. So BP2 is 30, IP2 is, so sorry, BP2 is 20, IP2 is 30, so it's 2 by 3, so basically 66.66%. So the answer is C. Thank you.